Hi there, and welcome to lesson 8.2 for pre-calculus. So today we're just going to start with lesson 8.1 or 8.2, but we're not actually going to finish it, and it's going to be a pretty short lesson. So let's go ahead and get started. First, we're going to learn about equality of matrices. So what does it mean for two matrices to be equal to each other? And what it means is that if their entries that are in equivalent positions are the same, then they are equivalent or equal matrices. So for example, we've got two matrices here. This is A where it's all in letters, and here we've got our numbers. So these two matrices are only going to be equal to each other if A sub 1, 1 equals 3, if A sub 1, 2 were to equal negative 1, if A sub 2, 1 would be 2, and if A sub 2, 2 is negative 2. So that's the only way that these would be equal to each other, and you'd have equivalent matrices because now we have them being the exact same. So all of the entries in the equivalent positions are equal to each other. And we can see that when we write this out, we've got the same values here. So that's what it means for matrices to be equal to each other. Now let's go ahead and move on to addition and subtraction of matrices. So when we're adding or subtracting matrices, you can only add entries that are in equivalent positions. So they have to be in the same spot. So for example, this 1 and this 3 are in the same spot. So we'd be able to add those or subtract them. And on top of that, we can only add matrices of the same order. So that's the first thing that you want to check, is make sure that they're of the same order and can we add these. So for example, these matrices, we have a 2 by 3 matrix over here and another 2 by 3 matrix. So because they're of the same order, we can add them. And when we add them, we're going to add the equivalent entries. So 1 plus 3 is 4. Then we now have negative 3 plus 1 is a negative 2. 2 minus 2 is going to be 0. 0 plus 4 is 4. 2 plus negative 1 is 1, and negative 4 plus 2 is a negative 2. So that's how you would add these two matrices together. So now let's move on to the next example. So again, remember, the first thing that you want to do is check their order. So here we have a 2 by 2 matrix, and here we have a 2 by 1 matrix. They're not the same, so therefore there is no solution or undefined. We cannot add or subtract these matrices. Okay, let's move on to scalar multiplication now. So remember from the vectors, when we were learning vectors earlier on, that multiplying by a scalar means that you're essentially multiplying it by a constant number. So we have matrix A here, and we want to find 3A. So 3A means that we are going to multiply every single thing here by 3. So 3A is going to give us the matrix 9, negative 3, 3 times 2 is 6, 3 times 1 is 3, 3 times 0 is 0, 3 times 3 is 9, 3 times 2 is 6, and 3 times 2 is 6. So we have now found 3A. Now we're going to do negative 2A. Negative 2A is going to turn everything negative and then double the numbers. So here we start back up with our A, so 3 times negative 2 is going to be negative 6. Negative 1 times negative 2 gives us a positive 2. 2 times a negative 2 is a negative 4. 1 times a negative 2 gives us negative 2. Negative 2 times 0 is 0. Negative 2 times 3 is negative 6. Negative 2 times 2 is negative 4. And negative 2 times 2 is negative 4. So that's how you would perform scalar multiplication on a matrix. So now now that we've done addition, subtraction, scalar multiplication, we're gonna actually review some of the properties of what happens to matrix addition and scalar multiplication. And these rules are ones that we have seen before. We've seen them with vectors, we've seen them with addition or real numbers, things like that. So the same rules apply. So for example, if we have A plus B, That's going to be, if we add these two matrices, matrix A plus matrix B, that's going to give us the same value as if we had added matrix B to matrix A, and so on and so forth. So if we have A plus B plus C, where we do our order of operations and we add B and C together first. So remember, these are all matrices. That would be the same thing as if we added matrix A to matrix B and then added that to matrix C. You're going to multiply the matrix A by the scalars C and D. If you multiply your scalars first, that's going to be the same as C times matrix D, or A times scalar D. 1, that is just your scalar of 1. So 1 times A will equal A. C times A plus B will give us CA plus CB. Remember, C is going to be a scalar. C plus D times A is equal to CA plus DA. And lastly, your zero matrix. And this is a matrix just all full of zeros. Every single entry in it is 0. So 0 plus A equals A. So that is it for today. It's a pretty short lesson, like I said. I hope you guys enjoyed this and look forward to seeing you. Take care. Bye-bye.